Greetings, Doctor. Today I'll be doing a short presentation for our statistics for this semester, and the presentation will be the relationship between blood donation and organ donation from Group 3. Group 3 consists of a total of 4 members: myself, Sarvin, Chua Tian Tian, and Angela Chua Sun Yi. There are a total of 5 objectives, the first of which is that we identify and justify the relevant variables involved in the claim. Secondly, we aggregate daily data into monthly totals for both blood donations and organ donations in Kedah. Next, we will analyze the correlation between two variables using scatter plot data and statistical measures such as correlation coefficient R and the coefficient of determination R squared. For number 4, we use linear regression to forecast future organ donation levels. And finally, we determine whether the data supports the healthcare organization's claim based on statistical evidence. This is the aggregated data that we've compiled in the form of an Excel table. Here we are showing the type of donation based on the monthly basis, where blood donation is X and organ donation is Y. We have also summed up several variables such as xy, x squared, and y2 to assist in future calculations. Here shown is the scatterplot graph that we have formed based on the aggregated data, and there's also a trend line showing the trend between organ donation and blood donation.
Greetings, Dr. Afiza. So next we'll see coefficient of correlation R. So to find R, you have to use the formula where R equals to Sxy over square root Sxx times by Syy. So to find Sxy, we got the answer 7557. For Sx square, we got 387006.25. Next, for Sy squared, we got 2482.67. So overall, to find R, we got R equals to 0.2438. That indicates a weak positive relationship between the variables x and y. Okay, next we will see coefficient of determination R squared, where we have to just square the R value. So the R value is 0.24538, and we have to square and we get 0.0595. Then we have to change it to percentage, where we will get 5.9%. So the value of R square equals to 5.9% indicates that only a small portion of the variance in the dependent variable y can be explained by the independent variable x through the regression model.
Good day, Dr. Hafiza. My name is Chua Tian Tian, number metric AP240377. Now I'm going to present regression line using the least square method. First, we need to find B1. B1 equal to Sxy divided Sxx, which means equal to 7557 divided 387006.25, which means the answer will be 0.0195268, and it can be shortened until to 0.01953. And next we need to find B0 equal y negative B1x, and it is means equal to 728 divided 12 negative 0.01955 in column, and 20815 divided 12, and the answer will be 60.6667 negative 0.01953 in column, 1734.5833 in column, and the final answer will be 26.79028815, and it can be shortened until to 26.7903. Last, we need to find y equal b0 plus b1x, which is y equal to 6.7903 plus 0.01953x, and the last answer will be x equal 0.01953 and y will be 26.7903. Through this calculation, the equation shows the relationship between two variables, x the independent variable and y the dependent variable. The intercept 26.7903 means that when x is 0, y is expected to be 26.7903. In short, this model helps us estimate or predict y based on any value of x, which showing us how change in x are linked to be change in y.
My name is Angela Twasingler, matric number AP240235. I would like to present the analysis result based on our data. The correlation coefficient R is 0.2438, which shows a weak but positive relationship between variable x and y. This means that when x increases, y also increases slightly, but the relationship is not strong. Next, we look at the coefficient of determination, which is R squared equal 0.0595 or about 5.95%. This tells us that only 5.95% of the variation in y can be explained by x using the linear model. The remaining 94.1% is due to other factors not included in this analysis. So overall, even though there is some linear connection between x and y, it is very minimal, and x alone is not a strong predictor of y.
I'm going to explain how we forecast the expected number of organ donation in January 2025 using linear regression based on the number of blood donation. We use the regression formula y equal b0 plus b1x, where y is the predicted organ donation and x is the number of blood donation. b1 is the slope and b0 is the intercept. First, we calculate the slope b1 using the formula sxy divided by sxx, that gives us b1 equal 7597 divided 387,006.25, which equal 0.01953. This means for every additional blood donation, organ donation is increased slightly by 0.01953. Next, we find the intercept B0. We calculate the average value of y and x. Average y equal to 728 divided by 12, and the answer is 60.67. And the average x is 20815 divided by 12, and the answer is 1734.58. Then we apply the formula B0 equals 60.67 negative in column 0.01953 times 1734.58, and the answer will be 26.7937. Now we plug both values into the regression equation, which is y equals 26.7937 plus 0.01953x. Forecast January 2025, we substitute x equal to 47248 and y will be equal to 26.7937 plus 0.01953 times 47248. Last answer will be equal to 950. Based on the given data, if there are 47248 blood donation, we can expect around 950 organ donation in January 2025. And these predictions show a weak but positive relationship between the two variables, meaning blood donation slightly influence organ donation, but other factors may also play a significant role.
In conclusion, based on the data collected from January to December, our analysis found a weak but positive relationship between blood donation and organ donation, with a correlation coefficient of R equal 0.2438. However, the coefficient of determination, which is only 5.9%, tells us that blood donation explains just a small part of organ donation behavior. So while the results slightly support to healthcare organizations' claim, it also suggests that other factors such as public awareness, cultural belief, and personal motivations have a much stronger impact. Therefore, we conclude that blood donation should not be used as the only predictor for organ donation winners, and future research should include a wider range of variables to better understand what truly influences people's decisions. That's all from me. Thank you.